Um, Welcome to like the second session. So now we're just gonna look through the solutions of that multiple choice question. So can you see everything properly?
Yes, sir.
Okay. So like from this we can see that 1.1 it stays COD. So you were right because I was mostly looking at D when they say it maintains its velocity when a non-zero force is acting on it. So when something maintains its velocity, that means um the velocity is kept constant. It doesn't accelerate, so there's no change in it. So from this, I can say, yeah, that's nice. Then they say the second question, when they say this person stands up on the fixed scale on the floor. So you said the reading will increase when the lift is actually going up in increasing speed. So do you understand like why it increases, or do I need to like explain further?
I understand, sir.
Sorry? Sorry, like I didn't hear you properly. Um, yeah, let me just put this here. So that's correct. And now we're gonna go to 1.3 when you say the object is projected upward, and you said the velocity is upward but the acceleration is downward. We understand that because like when you throw like a ball upward, it's gonna go up, but gravity will pull it down. So our gravitational acceleration is gonna pull it down, and our velocity is gonna go up. So I'm pretty sure that's a simple concept to understand. So that means like you got that one right too. And we go to 1.4 where ball Q rebounds at half the speed of ball P. So they say the kinetic energy is conserved for both ball P and Q. The change in momentum of ball P is greater than that of ball Q. Yeah, yeah, I think that's understandable because like there's gonna be greater change as the speed stays the same, as the speed is higher than that of ball Q. So V is greater than 1 over 2V. So the change in momentum is obviously gonna be higher. Then at 1.5, they say if work is done to a moving object is positive, then we can conclude that the kinetic energy of that object has increased. So yeah, 1.5, you also got it right. So we know that the kinetic energy of the object has increased because the work done is positive. So that means the kinetic energy is also positive. Then we're gonna get to the next one. This one is about the spectrum. So you said that when the frequency of the observed light increases, the distance between the asteroid and the Earth decreases. So that's our 1.6. That's A, which is correct also. Because as I said, frequency is inversely proportional to distance. So as the frequency increases, the distance decreases. So this one is about the spheres, where we know that X is negative and it pulls Y closer to it, but it repels Z. So we know that positive and negative attract, negative and negative repel, positive and positive repel. So from this, as X attracts Y and it repels Z, we know that this has to be positive because it's attracted to a negative, and this has to be a negative because it's repelled by a negative. So your answer was A, which is correct as well. And then we come down to this circuit where we have two circuits with the same resistors and the same cells with a negligible internal resistance. So the power dissipated in the resistor X is P, and the power dissipated in the resistor Y, that's gonna be as these two resistors are in parallel, the power is gonna be different from when they're in series. So from this we can know that like this, it's gonna be our P, which is gonna be equal to let's say 1 over R1 plus 1 over R2. So we're gonna have 1 over X. So I'm just gonna call all these resistors X because they have the same resistance. As you can see, they say the resistors and cells are identical. So even if like I label all these other resistors as X or Y, either way it's gonna be fine. Do you understand that?
Yes, sir.
Okay. So 1 over RP is going to be equal to 2 over X then I can just say 2 over x. The reciprocal of 2 over x is gonna be x over 2. So that's the resistance of this one, of this combination. Then we know, since like they're in parallel, like the voltage is gonna be the same. So now we have to find the relationship between power and resistance. So it's gonna be P is equal to IV. It's gonna be, so we're just gonna, since the system, it's gonna, since we know that I is equal to V over R, you know, it's gonna be uh, 1.8. But then here we can just assume, that the voltage is constant. The voltage is gonna be constant because the resistors are in parallel. So the amount of volts that this one receives is the amount of volts that this one receives. So can I check something real quick? So can I check something real quick? I'll be back now. What the fuck? You know, from all of this, it doesn't make sense because I don't think 1.8 should be D. But I'll do a bit of I'll do a bit more research on that and send it through to you. Because if I remember well, power is inversely proportional to resistance. But here, like, the power has increased, so I'm not sure about like the answer that I wrote down. But do you understand like why the answer is D?
Yes, sir.
Okay, yeah, enlighten me, man, because I think I forgot some of this stuff. Can you help me then?
Sir, I'm not completely sure. I just know that it couldn't have been the rest of them.
Oh, ow. But either way, like according to the memorandum, you got it. I just want like I think I'll have to do a bit more work on it. Then maybe like I'll explain it during like our next meeting. Or do you want it to be explained, or are you fine with it?
I'm fine with it, sir.
You're fine with it? Okay. Anyway, it looks like you know your stuff, to be honest. Like you know which properties do and don't affect the EMF, because here you say replacing the coil with a coil of lower resistance. So that's also correct, you know, because the number of turns actually do affect the EMF, do increase the EMF. The magnetic field does increase the EMF, making it stronger, increases the EMF, and making the coil rotate faster does increase the EMF. And here also, like you just got perfect 20 out of 20 according to the memorandum. Please. So are you satisfied?
Yes, sir.
Yeah, I just think like this is just gonna be the what we did today. I don't know. Do you have any questions?
No, sir.
Okay. So I'm just gonna wait for you guys to go to school. Then maybe on Sunday you'll have questions, or we can just do whichever topic or chapter you guys started at school, right?
Okay, sir.